out of 1 million.
All right, other questions? All right, what's the answer to mine?
It reacts to.
Okay, how?
So that means negative charge, right? The E.
Yep.
So they'll attract to each other.
Okay. That at least is consistent with what we talked about yesterday, or 2 days ago. All right, so they're opposite signs. This is a proton with the obviously positive, so P plus, that's the shorthand for proton. That's the shorthand for electron. So if an electron suddenly appears, everyone agree with Ibrahim that they'll attract to each other? Or is there anyone who doesn't agree? No one willing to take a chance on that, okay? How does the electron know the proton exists? The electron shows up with its ISR on and is scanning around and says, ooh, proton. How does one object know another object is there?
It's in its field of solid. That Matrix field.
That's the magic word right there. Yes, it was a field of something, more specifically, it's the electric field. This is the idea, this was a sort of a fundamental idea in physics, or question in physics, as how does one object know another one exists? So for example, from 151, I have two masses, they'll be attracted to each other. You have this idea of a gravitational field, or Einstein took it one step further and said, well, space itself is warped, and the mass doesn't know another mass exists, it's only reacting to the warping of space. So physicists came up with this idea that before the electron even shows up, the proton must be doing something. It's giving off some sort of, and no one else will call this but me, pheromones, electric pheromones out into the universe, and the electron has no idea that the proton exists. It only knows that there's these pheromones, and it goes to find the source of them. So, in constructing of this idea of the electric field, shorthand, E with a vector symbol over it. It is a vector quantity. They know that it's related to the force, but it only depends upon one particle. The electric field cannot depend upon the electron. It's not suddenly the electron shows up and the proton goes, oh, time to give off an electric field. The electric field has to exist before the electron shows, electric field has to show up before the electron shows up. And so they came up with, well, suppose we just take the force that would exist between the electron and the proton, times Q electron times Q proton, divided by the distance between them squared. Or this would be the force, the electric force on the electron. And they said, you know what, what happens if we just get rid of the charge of the electron? Well, the way you get rid of it is divide by it, so let's divide by the charge of the electron. And so we have the force that would be exerted on the electron divided by the charge of the electron, and we have the electric field of the proton. And so we have a math definition of the electric field of a proton, of that proton, is equal to Coulomb's constant times the charge of the proton divided by the distance squared and the direction of the radial vector of the proton. So Ke, that's a positive constant, roughly 9 times 10 to the 9th, and yes, SI units. Charge of a proton, well, that's positive. Distance is a positive number. So all of this is positive, which means that the direction is in the positive r plus direction. In other words, if I have a positive charge, here, the electric field goes away from it. And you just draw this till you get tired of drawing lines. So this electric field exists out in space, and so if r is the distance from the center of the charge to the point in space that we care about, what is the electric field at that point? That would be the type of question. So let's do some numbers here.
Dr. Fox?
Yes.
In the original equation, before you made it, that one, you divide by the charge of the electron on the left. I get why it disappears on the right, but why is it on the left?
Because mathematically, if I do it to the right, I have to do it to the left.
Yeah, but I'm saying, why isn't it on the left in that equation?
Because I divided by it. All right, so this is the force, that's the electric field. There are two different quantities. This is the force that would be on the electron divided by the charge of the electron. I feel like I'm missing your question.
No, you got it.
Okay. All right.
So the electric field is equal to the force of E negative over charge of E.
Right. And for the sake of how we would use that later, more apt to do it this way is that the force on any charge is equal to the electric field wherever that charge is times the charge itself. What we're heading towards is a different way of looking at this. Instead of looking at it in terms of what are distribution of all the charges, we can later on look at, oh, I have an electric field here. Don't care what causes that electric field. All I know is there's an electric field here. How is a charge going to react to that? Okay. Other questions at this point?
What if you just don't get tired of drawing the lines?
Then you'll be doing it a long time. All right, so let's say that this distance here is 4 meters and 3 meters. What is the electric field? And we'll call this point M. What is the electric field at point M? Or how would you go about solving it?
Would you do some triangle math or no?
At some point. All right, Jack got it started. We're on a roll. Formula. What's the formula?
Coulomb's constant.
Okay, so 9 times 10 to the 9th.
Times the charge of the proton.
All right, 1.6 times 10 to the negative 19.
Over 25.
Five squared. For those who aren't sure how we got that, how'd you get 5? It's a right triangle here. I care about this distance. That Pythagorean theorem. And we end up with
did we get the 1.6 E? Is that the is that just an equation that just is?
1.6 times 10 to the negative 19. On calculators, this is generally represented by an E or two E's, and it's just saving time.
But what is?
But it's just a number that just is, it's the charge of an electron.
Oh, the 1.6 times 10 to the negative 19, charge of a proton.
Oh.
It's positive.
Can you say it one more time? Charge of?
This right here is the charge of a proton in coulombs.
5.76 times, or 5.76 E negative 11.
And if this were a 10-point problem, I'd give you 4 points for it. I'm assuming you did the math correctly.
5.76 E.
Or times 10 to the negative 11. Again,
So is
using
it
sloppy notation.
the units,
All right, that would take care of 3 points. What should the units be?
isn't that
Newton
micro?
No, micro's not showing up in this
Oh,
one.
okay.
Newton coulombs.
So close.
Coulomb squared divided by.
All right. We have two formulas here for the electric field. We have the one that we plugged into. We also have this one over here. What would the units here be?
Newton coulomb squared.
You're farther away. You walked out of the ballpark and now you're trying to find your car.
Oh, Newton per. Newton's per coulomb.
It was per coulomb.
Oh, so when I said Newton coulombs, that assumes multiplication, right?
Yes.
Oh.
I've taken it that you would have written it down correctly.
Yeah.
Okay. So now only minus 3 points.
And then the direction.
Yes. How do you want to do this polar form or do you want to do it in rectangular form?
What's the difference? The
One rectangular form is we have an I hat, J hat, and in polar form you have magnitude, angle.
I had you.
He said polar first.
Interesting.
What the heck? Let's just do it both. Celebration of math. All right. So if we want to find that angle, again, 0 degrees this way, unless you state otherwise. We're going with the math convention. You don't have to restate that part. So 0 degrees, 90 degrees, 180, 270, 360, or 0, and then negative going in the other direction. So it's a first quadrant angle. In other words, I'm trying to find that angle right there. We can go for the typical stunning visual effects until the board decides to change the color. How would you find that angle? I know that the tangent of theta is the opposite over the adjacent, and therefore theta would be the arctan of 3/4, and it is change color there at least. And you end up with somewhere around 36.8 something degrees. So it's about to tell me.
8.7.
8.7. So this angle, 36.87 degrees. So we can express our answer as 5.76 times 10 to the negative 11 newtons per coulomb, 36.87 degrees. Polar form. Dramatic pause for questions.
Does it matter if you do rectangular or polar? Is there one better than the other?
It depends on what you're doing next. In this particular case, I personally would think that polar is just simpler of all it is, what's the electric field? If I'm asking you to add electric fields, probably rectangular form would be very convenient, but if I don't specify, whatever your mood is at the moment. Ali, obviously, in a polar mood.
we do a polar form, would we redo the first equation, but do it like 16 on bottom and then 9 on bottom, and then those are the two directions?
No, definitely not. And that is what, that's one of the reasons I am gonna do rectangular next, not just because Evelyn wants it, but in spite of that. Sorry, distracted myself. That's the most common mistake I see. All right, so let's do rectangular. Flashback. In essence, I'm gonna simplify it here. 5.76 of the hypotenuse. This is a 36.87 degree angle. We are breaking this up. Or if you prefer to do the similar triangle method, that's 3, 4, and 5. So I need to figure out what those are. 5.76 is to 5, as the horizontal is to 4. 5.76 is to 5, as that is to 3, which is the essence of trig. Trig just makes it simpler at times. X and Y. As X is to 4.
4.608.
And Y?
3.456.
4, 5, 6?
Yeah.
So in rectangular form, we end up with 4.60, let's define a coordinate system here. 4.7608 times 10 to the negative 11th newtons per coulomb I hat plus 3.456 times 10 to the negative 11th newtons per coulomb J hat. Do not try to find the horizontal component by dividing by 16 squared and then dividing by 3 squared. You need to do it by the actual distance squared, the 5 squared, and then multiply times the ratio.
So, would we have gotten, wait, so you want the decimals is what you're saying?
I want the decimal. I want the correct answer, whether the decimal or not.
Understood. So had we done it the 16 or?
If you've done
It would've
the
been
KQ over 4 squared I hat plus that squared over 3 hat J squared, that would just been wrong.
wrong.
Because think about that, if I'm dealing with, let's say, the proton here and I want the electric field at this point. The horizontal component, what's the horizontal component for that?
Is it the 0?
So if you divide it by 0 squared,
That's not gonna work.
you'd get something that'd be like an infinitely large electric field, which it's not.
How did we get the Y? Is it the exact same thing we just did with X?
Yeah, so if you're doing ratio of similar triangles, that is to 5 as Y is to 3.
Okay. That's times 10 to the power negative 1.
Or Y is 5.76 times, times the sine of 36.87 degrees, and X is 5.76 times the cosine of 36.87 degrees. For those who like to use trig more explicitly.
So it's just the 3, 4, 5 triangle is just a function then? Or
I trailed off there. The 3, 4, 5 triangle is,
It's just like a function kind of thing?
what would you mean by that?
Like, is it just a thing that you can use to get that answer? Or is it related to this problem? Like, is the actual triangle?
Well, 3, 4, 5 triangle shows up enough that it's just a little bit simpler, but regardless of what the ratio, what they are, the process is the same. All right, any questions?
Oh, I see. We used the 3, 4, 5 because it started with 3, 4, 5, right?
Yes.
So that's why we were able
Oh,
to set it
yeah.
equal to.
Originally, I started with a 3, 4, 5 triangle, and so that's why I'm using it over there.
So I have a question, this is just in general. Okay, so the I-hat and J-hat. So, you know, they're in like, for the X and Y axis.
That's the way I defined it here.
Okay, so if someone puts X for like Y and then Y for J,
So X hat and Y hat,
yeah,
you still need the hats.
okay.
Yeah, if you're defining an X hat, Y hat, just, you can call it squiggle hat and triangle hat if you want.
You just need the hat.
Yeah, the hat's indicating that we're talking about a direction.
Okay.
That's the 5-dimensional. All right, so suppose we have an electron instead of a proton. It goes off immediately, just pushing through. Any other questions? All right, then I was right to just shoot on ahead. And I put the stylus here. There we go. All right, if I have an electron, well, I know my electric field is going to be K sub E or C, whichever one my mood is at the moment, times the charge divided by the distance squared. Gave it down a little bit more. I know K sub E or K sub C is a constant, it's positive. I